which the simplest way to define them is it's a mechanism in JavaScript for handling scope. Okay, so we've talked about before, like things being in the global scope or the local scope. To use Python as an example, if I were to define a variable x and I were to put it into a function, right, and then later on I said print x, it would not be able to do that because it's a local variable within the local scope of that function. What are two things that I could do to fix that problem in Python? There are a few ways, but there are two like pretty common ways to do that.
So I think I understood the question, but couldn't you like declare it as a global variable?
Yep, that's number one. Put global in front of it, make it a global variable, absolutely. The other one you're all probably overthinking. I could just not define it within the function, right? I could just define it outside of the scope of the function, which is to say like on the first line or something, and then every function in that program has global access to that, right? You should always take care to not be mindful of scope, I guess is what I should say, right? Be mindful of what has access to what in your program, and make sure if something needs access, it has it, but also make sure that something doesn't have more access than it needs, right? In C# we talked about the idea of protected, which is, and protected also exists in PHP as well. And it's similar to private, but it gives you a little more flexibility than private does. Okay, so we're gonna talk about closures, and then we're gonna talk about reference versus value in JavaScript, okay? And then we'll take us a break and go to lab time, at which point I will have that video up on YouTube for you to start on that project. And just to give you a heads up, it's a Zoom clone. Now, it's not a Zoom clone that's gonna go make you millions of dollars probably, but it should give you an idea of how to work with the WebRTC library, which should allow you to do, to give you an example, what if you wanted to add, you have to do some other stuff to make this happen, but what if you wanted to add multiplayer functionality to that arena RPG that we made, right? You could have a situation where you have a little video window for each person, and you could actually talk to each other. Like Hearthstone doesn't have that. It'd be really kind of cool if it did, you know, so you could like chat with the person while you're battling them. So anyway, we will do that. So let's, without further ado, hop over here and talk about JavaScript closures. Nothing to follow along with here, just use your eyeballs and ears and see if you don't maybe perhaps learn something. One more thing, yesterday I mentioned during web dev in the afternoon that my method and my strategy when it comes to instruction is I used to be really lecture heavy and PowerPoint heavy, where I would, and I'm still that way in like 120 and stuff, but I would just do these like long in-depth lectures, right? And then I would be like, okay, so let's take a test or what, you know, whatever. And what ended up happening was people weren't having a good time. People, like, they would come in here and just, it was so dry and boring. And so what I like to try to do is just like show you some different concepts and projects and stuff by different people, and hopefully it will sink in over time. That eventually you'll get to a point where because I mean, in Python, for example, you don't just make a program, right? You gotta plan it out a little bit and be like, well, what variables do I need? What functions do I need? Things like that. It's the same way with JavaScript. You know, you might not know how to do something from the ground up without any assistance, but hopefully by the end of this course you'll have enough understanding of JavaScript basics and what JavaScript can do that you can start planning things out, and then if you need to Google, how was it that I used this library again? How is it Node.js works? And just refresh yourself as needed. Does that make sense? Okay, so let's hop over here and let's check out, Kyle, could you grab the lights for me, please? It is the backlight switch, the one on the right. All right, let's check this out. Thanks, sir.
Hello everyone. In today's video, I'm going to be explaining to you exactly what closures are, and you'll be surprised how simple they are to understand once you wrap your head around the idea. So let's get started now. Welcome back to Web Dev Simplified. My name's Kyle, and my job is to simplify the web for you So if that sounds interesting, make sure you subscribe to the channel for more videos just like this one. And now to get started, I just have really simple JavaScript on the left side here, and then the output showing up on the right hand side. And this is very simple code. We have a variable called myName, a function called printName, which prints out our name whenever we call it, and then we're calling that function. And as you can see, we're getting Kyle printed out over here on the side. And what you probably don't realize is this is using closures. This entire thing is one giant closure. And that's because most of the time when you run code in other languages, for example, you cannot access variables outside of a function inside of that function. That is just not always possible in other languages, but it is possible in JavaScript. And it is what we call a closure. So this variable that is external to this function is actually available internally inside this function. This is a global variable essentially, and it's available inside this function. And the way closures work in JavaScript is that every scope, so for example, we have the entire JavaScript file, that is one scope, and then our function is another scope. So every scope has access to everything outside of its scope. So our function has an outer scope of our entire file, so it has access to everything inside the outer file. And one thing that's really interesting is if we change this here to a variable that can be renamed. So we have our name as Kyle up here, and then we change our name down here. We'll just say that the new name is going to be Joey, and we save that. You can see this now prints out Joey. And so it's not just taking the name that is defined when the function is defined, it's actually taking the current live value of that name. Because for example, if we have the name here, and then we come down here, change the name to something else, we'll change it to Kate, and then we print out the name one more time, you can see that it says Joey and then Kate. It's constantly going with whatever the most recent value of that variable is. And now this right here is not the most useful way that you can use closures. I mean, it obviously is a way you can use them, but when most people think of closures, they think of functions inside of other functions. So let me jump to another example now. So here is the more common use case of closures where most people talk about closures. And as you can see, we have a function here called outer function, and that function is returning another function inside of it called inner function. And as you can see down here, we're calling outer function with the variable outside. So now we are getting a new function. And then lastly, we're calling that new function with the variable inside. So what's happening is that when we first call this outer function, we have this outer variable, which we set to outside, which gets set. And then we have this function that gets returned here. And the reason we're able to access this outer variable inside of this function is because of closures. And now it's kind of weird when you think about it at first because this outer function runs and this outer variable is only available inside this function. But this function is done executing. For example, if we just remove this code here, you can see nothing prints out. And that's because we call this outer function right here and it executes all of the code and then it's done executing. And this outer variable is no longer accessible. For example, I can't log out the outer variable. If I try to, it's just going to give me an error. As you can see, it doesn't actually exist. So how is the inner function able to access this outer variable even after it's done being executed? Because the outer variable has gone out of scope. And that is where closures come in. So what happens is this inner function is essentially saying, okay, I'm inside this outer function. It has this outer variable, so I'm going to save this outer variable. I'm going to make sure I know what this outer variable is at all times. And even if the function that defined this variable is no longer executed anymore, it exits out of the function, it's okay. I'm still going to keep track of the outer variable. And that's why you can see outer is being printed out outside here. And we have the inner variable also being printed out. If I, for example, pass in an inner variable, you can see it gets printed out right there. And the most common use case for this a lot of times is to have variables that you pass into functions that can then be accessed inside of other functions. We could also create a variable inside of here. We're going to call this outer2, and we're going to set this equal to hi. And we can also log that inside of here. So we can say console.log outer2, and you can see hi is being printed out. Again, this is inside the scope that is outside this function. So this function is contained inside this function. So everything in the outer function is available inside the inner function, since in JavaScript, anything on the inside has access to the things on the outside of its scope. Essentially, it has access to its parent scope, its parent's parent scope, and so on. Everything that is outside of it. And it has access, of course, to the things inside of it. Now this here is a fairly contrived example, so probably one of the more common use cases where you're going to see this is if you're using something like Axios or fetch. So if we come in here and we have a function that's going to do fetch, so we want to fetch, for example, some URL. So we're going to just say, URL, whatever it is, some random URL that you're fetching. And then inside of here, you're going to have an actual promise that's being returned. So we can say .then, and this is going to take a function. And this function is a function that's inside our outer function. And inside of here, we would have access to our outer variable. So we could say outer variable, for example. And in most cases, we'd probably pass in the URL here, and we'd pass it in here. And again, we'd have access to that URL inside this inner function. And now, obviously, this looks a bit different. This is an arrow function, not a standard function. But either way, it's still a function defined inside of another function. And this inner function has access to all of the scope of this outer function. So it has access to this URL variable, even though this fetch is only going to call this .then function long after outer function is done being called. Really, all you need to know about closures is that when you have a function defined inside of another function like this, that inner function has access to the variables and scope of the outer function, even if the outer function finishes executing and those variables are no longer accessible outside that function. So if you enjoyed that video, make sure to check out my other.
Okay, so maybe a little complicated to wrap your mind around, but think about it like this, and maybe this will help. What was he, in C# terms, not in web terms, in C# terms, what was he kind of describing there? What type of access was he sort of describing? I just talked about it a minute ago. A situation where something has access to all of its parents' variables and such? What kind of scope is that?
Protected?
Yeah, protected, exactly. That's how protected effectively works in C#. It's not exactly the same, but it's pretty similar, right? You have public, which means that everybody anywhere in the program, a piece of code can access that thing. Then you have private, which means only that thing can access it, right? So if I have like a class that has like a private method or something like that, right? Or like a private variable, that sort of thing. Only that class can access it. Protected, on the other hand, means that that class, as well as any classes derived from it, can also access it. So if I have a person class and something is protected, then if I have a student class and a teacher class that are derived from that one, they also can access that protected thing. Does that make sense?
Correct me if I'm wrong, it's been a little while since I've taken C#. In C#, you basically decide which of those you use though, correct?
Yes, that would be amazing.
So in JavaScript, it's
automatic.
It is automatic.
There's no special. Now, you may recall that let versus var affects scope. Okay, so you do need to be mindful of that. That would be a scenario. So if there's no, since it does it automatically for you, you could probably use var. I would recommend using var. That way, you just let JavaScript take care of it. But if there's a scenario where you need to have some sort of scope control, use let. That way you're controlling it there, and then let JavaScript take care of the rest. Does that make sense? And in that instance, you would just avoid nesting functions together, right? And that would take care of any scope issues. But no, it's you don't explicitly you don't explicitly do it the way that you do it in C#. No. Great.
Is there drawbacks? I'm trying to think. Is there drawbacks to it being automatic in that way? Because it doesn't seem like you have quite as much control over that as you do. I mean, like you're saying, in C# you have what, 3 options?
Yeah.
And you decide that.
You do. Well, okay, so it's a really good question. I'm trying to think of how to phrase this. Okay, so like to give you an example, okay, so if you declare a variable on like the first line or something. Remember the example that he gave, and then like later he redefined that variable.
Right.
Do you remember that? Okay. So what I would recommend, and how I would explain it, is if you, as you're writing your code, be mindful of those sorts of things, right? So like consider like, okay, do I want the whole program to have access to this thing? Like, do I need to declare it outside of a function and give it complete global scope, right? Do I need to declare it inside of a function full stop and give it a private scope? Or do I need to define it within a nested function and give it protected scope? Does that make sense?
So I guess, yeah. So I guess technically you do still have
So you do, yeah. So you are making those choices. Yeah, you are doing it. It just isn't quite as explicit. Yeah, like the syntax of it is a little different. Instead of like explicitly saying public static void, all the stuff that you have to put with like, you know, in like C#, you just sort of put it where it goes, if that makes sense. And then JavaScript kind of sorts all of the nitty gritty out for you.
Yeah, it kind of seems like in JavaScript maybe you need a deeper understanding of how, I guess, either how JavaScript does that or how scope works.
Yeah, exactly.
You kind of just like, you set it as it is, and you
exactly.
don't worry about that kind of thing, but I guess...
And that's one big nice thing about, that's why C# is easier to teach complex topics on than JavaScript is, because C#, Microsoft has designed it in such a way that it like does a lot of that heavy lifting for you, whereas in JavaScript, you really kind of have to know.
You at least have to know what it's doing.
Know what it's doing, yeah, exactly. Which sounds stupid. Like, oh, of course you should know what it's doing, but like more so than a lot of other things that I teach in this program, I would say JavaScript is the most like philosophical, I guess. Like, you know, you really need to understand like kind of at a deeper level what is actually occurring. Not just like, well, when I do this, I write it this way. You need to actually understand what ramifications that may have as far as like your program is concerned, as far as like scope goes and that sort of thing. Okay, awesome. Now, this was a little bit longer, but we are going to discuss values and references. Okay, now in C#1 I've talked about this already. What are value data types? What are they also known as? Any idea at all? So, okay, to give you some examples of them, maybe this will help. Int is a value data type. Char is a value data type. Bool is a value data type. String is a reference data type. So what might we also call value data types?
Primitive.
Primitive, yeah, exactly. They're primitive data types because they can contain only one type of data. They can contain a value, and that's it. Okay? Arrays/lists, objects/classes. I guess methods, if you want to think of them that way, they're not really data types, but I mean they're similar. And then of course strings. And the reason is because they can contain lots of stuff, not just like one type of data, like, you know, that this thing is equal to 5 or whatever. This thing is equal to a list of my friends' names, or this thing is equal to the string hello world, right? Hello world exclamation point, or 1 2 3 4 5, that kind of stuff, right? So anyway, we're going to take a bit of a deeper dive than that, but we're going to discuss reference versus value. I like to chain these two videos together because they kind of don't really tackle the same things, but they kind of do on a philosophical level, sort of like what we were just talking about. That this is a common issue that people run into in Python is they will do something like they'll have an object called like person1 or something, and person1 will have a name, okay? And they'll be like, well, I want to print out person1's name. And so they'll write print person1, forgetting the dot name at the end. And what happens when you do that?
Doesn't it like print out everything in the like memory location?
Yeah, it prints out its location in memory, exactly. And that weird like little like angle bracket line of thing that it gives you. Yeah, exactly. And so understanding why that is the case, that we're not accessing a value, we're accessing a reference to an object in memory, right? And understanding what the difference in those two are is pretty important as far as making your JavaScript stuff bug free. Okay, so let's hop over and check this video out.
In today's video, we're going to be covering one of the most important topics of programming, and that's the idea of pass by value and pass by reference, what the differences between them are, as well as what each one is in depth. And the reason this is so important to understand is because when you're programming, if you don't have a strong understanding of what pass by value and pass by reference actually means and what they're doing to your code, you're going to run into tons and tons of bugs related to these issues, and they're incredibly hard to track down and debug if you don't understand pass by value and pass by reference. Not only that, almost any time that you go to interview for a job, they're going to ask you some question related to value and reference passing, and if you don't understand it, that's immediately a red flag for them since they know how important and fundamental this skill is. So without any further ado, let's get started now. Welcome back to Web Dev Simplified. My name's Kyle, and if you're new around here, make sure to subscribe for more videos where I simplify the web for you. Now in this video, we're going to be talking about pass by value and pass by reference and the difference between the two. And to start, we're going to look at a visual example of how pass by value and pass by reference work. And then after that's done, we're going to jump into some code examples so you can see live how these two things interact with each other. So let's jump over to the visual example. And here we are, riveting. I know it looks amazing, but as you can see, we just have some really simple code up in this top section, setting two variables, a and b, to the values of 10 and high. And down here is going to be how we visually track what all these variables are set to in order to determine if it's pass by value or pass by reference. So as we can know, for example here, a, the variable is going to have a value of 10, and b is going to have the variable value of high, and these are actually pass by value. So when you're setting a variable to a value such as 10, such as a string, so number, string, boolean, any of those basic primitive types, you're going to be using pass by value or setting a variable by value. And essentially what that means is that this value column of the variable is going to be set to an actual value, what the variable actually equals, for example, 10 or high, or maybe true or false or 10.2, whatever that value turns out to be. And the way that this works in JavaScript is that you take anything that's on the right-hand side of the equal, as we can see, this 10 value here, and what it does is it copies the value of this variable into the variable on the right-hand side. And 10, since it's just a value of 10, it's just going to copy 10 into the value for the variable a, as we can see down here. Same thing with high for the string b. Now let's move on a little bit from here, and as you can see, we added another variable, which is c, and we're setting it equal to the variable a. And you've probably done this tons of times while you're programming, so you know for a fact that c is going to be set to 10 because that's what the value of a is. And as I remember earlier, what we do is we take the value of the variable on the right, in our case a, which is 10, and we set that to the value of the variable on the left, which is c, so we have c as the variable and the value of 10. This is all very standard stuff that you're probably used to, and this is what pass by value, or setting things by value, just the idea of value, is referred to. So now let's go a step further, and if we move on here, we can see that now what we want to do is we want to add 1 to c, and then we want to save that back to c. So essentially we're saying 10 plus 1 is going to be 11, and we want to save that to c. Well, what actually happens to the value of a, and what happens to the value of c? Well, you've probably done this tons of times, so you know for a fact that c is going to be set to 11, and a is going to be set by 10. And the reason this happens is because c is set to a value. It's not a reference, it's actually a value of 10, and a has a value of 10, but these are two different 10s. They refer to two different values. So when you actually update c, you're going to be updating it with the value of 11, and you're not going to be touching a because c doesn't reference a, it points to the value 10, and it's updating that value 10, and a points to its own value 10. They're completely distinct from each other. And that's the difference between pass by value and pass by reference, as we're going to see in just a little bit. Now let's move on to this scenario, which is going to be where we're setting c to an array. So what is c's value going to be? You would think that it would have the value of the array 1, 2, but actually with JavaScript, arrays and objects, and essentially anything that's not the primitive type of string, number, boolean, etc., those are going to be passed by reference. So instead, you're going to be storing a reference to that object inside the value here. So if we move forward, we can see the value for C is actually just a memory address. So
all right, there we go. That's what I was talking about. Also, my understanding is that, okay, so you know how he just mentioned that a string is a value data type, okay? It is in this respect, but in terms of storage, stack versus heap, remember we talked about that, which like we don't really get into until C#2. But stack versus heap, in that regard, it is a reference data type because it can hold multiple types of data. Does that make sense? Okay, but in terms of value versus reference and what we're talking about now, it's a primitive data type. Okay, so just want to clear up any confusion there. But yeah, now there's our old friend, the angle bracketed memory address, right? So, and I really like talking about this because when I first figured this out years ago, because for probably the first 2 years that I was working in Python, ages and ages ago, I would occasionally make that mistake and get that memory address, and I would be like, what is going on? I mean, not that it mattered, but I was like, what is that? Like, why is it just throwing random numbers and letters at me or whatever? And then I found out it was its memory address, and I was like, that's the coolest thing I've ever heard in my entire life, because then I got this, it gave me this kind of like renewed understanding of how data is stored in a program, right? It's just like, okay, so it's not just like stored, right? It's like it has an address, just like there's like a house has an address, and it's like that's where that is stored in the computer's memory, at least during the execution of that particular program. And it's just, I found that fascinating. So anyway, yes, now we're going to be looking at the memory address.
someplace inside the memory of your computer, you're going to have an address, let's say for example 01, and it has the value here 12, which is the actual value of that array. And C just stores a reference to that memory address. So it works very similarly to how the variables worked, because you're still storing that value, but you're storing it inside of a memory address, and the variable is pointing to that address, if that makes sense. When you call C, you're not actually getting this value here returned, this 0x01, you're actually being returned the value of the memory at that location, but the variable itself is only storing a reference to that memory. And that's where you may run into problems when you're doing pass by reference and pass by value, as we'll see in just a little bit. If we move forward and we set a new variable d equal to c, what would actually happen? If we follow our previous example, when we created a new variable c and set it to a, we know that c just took the value from a and used that for the value of d. And that's exactly how pass by reference works too. Essentially, this is just like JavaScript. We take the value of the variable on the right, in our case it's this 0x01, and we set that to the value of the variable on the left. And if we move forward, you can see here that we have that reference being set for c and d. But you will notice that there's no more memory being allocated. Both c and d point to the exact same memory address, which means c and d are referencing the exact same piece of memory inside of your code, which is where you're going to run into problems if you don't realize how this works. If we move forward one step further, you can see if we want to add a new variable, we say d.push3, so we're adding the element 3 to our array, it's actually changing both c and d because they both point to the same address. As you can see, our new value for this address is 123 since we added 3 to the end of our array, but now c and d, since they both reference the address over here, they're actually both changed even though we only changed the variable d. And this is where all the time you're going to run into bugs if you don't understand how this works. I know personally when I was learning, and even still now, I run into problems all the time where I forget something's by reference and I update it and it somehow updates some other variable that's also referencing the same thing, and I run into bugs because of that. So you really need to make sure you understand in depth how this works. Now let's go one step further and actually set d to a brand new variable. This is going to be the variable 345. And what this does is this 345 variable is someplace in memory somewhere. It hasn't been defined yet, just like this 12 hasn't been. So we set a new address over here, for example 02, and that's going to have the value of 345. And then c up here is just still going to reference that 01, but now d is referencing 02. And again, that very first rule that I mentioned, where in JavaScript you take the value of whatever's on the right, in our case 345 has the memory address of 02, so we take that 02 value and we set it to d. So we're overwriting the value of d. And since we're overwriting the value of d, we're not actually changing the value of c. Only when we change what's at the actual address, that memory, is when we end up changing both of them. But since we're completely overriding the value stored in D, we're not actually changing anything to do with C. So now if we update D or we update C, it's not going to affect each other. They're completely different values at this point. Now this all seems really confusing at first when you take a look at it, but let's jump into some live examples and be able to understand how these work just a little bit better. So I've essentially recreated our very first example where we had two variables, A and B, both set to primitive values, so these are actually stored by value, and I'm just printing them out down here. We have A and B being printed out, and as you can see, A equals 10 and B equals high, pretty self-explanatory. Let's add in that variable C, and we're going to set it here equal to A, and then we're just going to come down here and print out C, just so we can make sure that this is working like I said it would earlier. And as you can see, C is also set to 10. But what happens when we want to update C? We want to add 1 to C, so we can say C is equal to C plus 1. And now if we save, you'll see, like I mentioned earlier, A stays as 10, but C updates to 11. This is how the pass by value is working, just as I explained earlier. Now let's jump in here with an example with arrays. We can come in here and say that this is just going to be the array 1, 2. If I save, you can see C is the array of 1, 2. And if I come down here and I set D, and I set that equal to C, and then I make sure I print out D, just like this, we can see that D is also equal to that array 1, 2. And like I mentioned earlier, D.push of 3, this is going to modify both C and D because they both point to the exact same value in memory. But if instead I set D equal to the array, for example, we'll just say 3, 4, 5, and now I save that, you can see that C and D are different. And then if, for example, I just said D.push of 6, you can see I'm only modifying D, I'm not also modifying C, and this is because they actually point to two different places in memory instead of the same location. And again, this is all what we really talked about earlier in the video. I'm just trying to reiterate and show you that this is how it truly works. And something that's really important by the pass by reference is let's make sure we set here D back to C. And if we wanted to check equality between C and D to see if they're the exact same array, we could just say in here, let's do C, we're going to do triple equals to D, and then we just want to say C triple equals D. So we want to see what that returns, and we also want to check what double equals returns. We're going to remove all this extra code we're not using, and if we save this, you can see that C triple equals D is true, and C double equals D is also true. But what happens if we come in here and we set D to the exact same array as C, but we don't actually reference C inside of it, and we click save, you can see that now these are equal to false. And the reason for this is because when we're using the equal sign to compare two different objects, for example, these two arrays, it's actually checking the value, the part that we looked at earlier, that variable value section where we had the memory address being stored. And these are two different memory locations because the value of 1, 2 is, for example, let's just say that this is going to have the memory address of 0x01, and down here we have 0x02, just for example. That's what they're going to be. So when we compare this, we're comparing 0x01 to 0x02, and of course this is not correct. But when we set D equal to C, this is actually setting both D and C to that same exact memory address. And if we save again, you'll get the trues over here. And the reason that when we create this second array, even though it's exactly the same array, since we're creating it on a separate line after the equal sign, it's going to have a separate memory address than the array that's up here, even though they have the exact same elements. That's something that will trip up a ton of people, especially when you're trying to compare arrays or objects. So you really need to make sure that you're comparing and knowing if you're comparing by reference or comparing by value. Another case where this is incredibly important, and probably the most important case where you're going to have to deal with passing by value and passing by reference, is when you're dealing with functions. So let's come down here and we're just going to create a function. We're going to call it add, and it's going to take in an array and it's going to take an element. And essentially all this is going to do is it's going to add that element to the array. So we're going to say array.push element. There we go, just like that. And now what we're going to do is we're just going to come in here and we're going to call that add function with C. So now C is going to have the element 3, let's say, appended to the end of it. And what we want to do is we want to log out what C is. So we're just going to say C is equal to C, and we're going to do this before and after, just like this. So what we're doing is we have our variable 1, 2, our array, then we're printing out what that equals to, adding 3 to the end of it, and then printing out what it equals again. And if we save, you can see we get 1, 2 as our array, and then 1, 2, 3. And you may be wondering, Why exactly is that? Why is it that when we pass this array to this function, it's actually having the value appended to it? And that's because this function is taking the value of that variable. In our case, our variable here, as we said earlier, let's just say that it's going to be a variable memory address of 1. That is actually what's being passed down here. This is essentially like passing this and the value 3. This is what's being passed into our function. So when we're saying push, we're pushing to that exact memory address, which is something that you may not actually realize you're doing. You may not realize when you pass an array or an object down to a function and you change it, you actually change the array or object that's outside of the function as well. One thing that can be a little confusing though is if inside of this function, instead, we just said that array is going to be equal to an empty array with that element inside of it. And now if we do this and save, you can see that our variable is still exactly the same, 1, 2, and 1, 2. And that's because we're passing down the memory address of 0x01, that's what array is. But when we use the equal sign, like I mentioned, we're actually copying the value from this new array and setting it into our array. So now, array here is essentially equal to that memory address 0x02, which is the new address of this new element we created, so it no longer references this external array over here, which we were originally modifying with the push command. This is something you don't have to worry about with non-passed by reference values though. For example, this element is just a number, the number 3, and we know that numbers are passed by value. So it actually just passes the 3 here. There's no memory address to worry about, no shared context, nothing like that. You just know it's passing 3, and it doesn't matter what we do to element. For example, if we change this back to how it was before, just like this, what we could do is we could say that element plus 2 is going to be set to our element. So let's, copy that out. We can say element is equal to element plus 2, and we can put our element inside of here. And if we save this and run it, you'll see that it adds 5 to the end because it's just element plus 2, but we're not actually modifying our element or anything like that outside of the function because it's passed by value, so anything we do to it is not going to affect things outside of it. In conclusion, what you need to know is that primitive values such as numbers, booleans, strings, undefined, null, those are all passed by value, and other things such as arrays, objects, and classes, those are all passed by reference and can thus be modified. This is why when you set an array to a constant variable, you're still able to do c.push, for example, of 3. Let's just get rid of all this extra code. For example, we can actually change this variable, as you can see over here, because the value that is being constant is that memory reference of 0x01, for example. That's what can't change. But what we actually store at that memory address can change. And with that, you know everything you need to know about
In conclusion, JavaScript. But before, I have a hunch I know what your question is going to be. So let me address this, and then we'll see if that is in fact the case. So you know how I've talked several times about, well, why in the world are you making that a constant? It is changing. That's what I'm talking about. The value may change, but the memory space it takes up does not. Does that make sense? That's why I can say I have a constant function or a constant variable, but I can change its value. You can't change its reference, but you can change its value. Okay? So now, your question.
Clarification.
Yes.
The double and triple equals, the difference between those is one of them checks for type as well, correct? Well, they both compare the value of what you're comparing, and then one of them checks for type.
I think that's correct, and I think
Triple, I think checks for type.
I think it's the other way around, because I think it.
I thought double just converted. It doesn't matter what type.
I think the triple prevents any automatic type conversion from happening.
Is that what it is? Okay, because I never can remember because C# does it I think slightly differently, and so yeah, so it's that.
So double automatically converts and
Triple prevents automatic type conversion.
Checks for both.
I think that's how it works.
Okay, that sounds correct, but totally unrelated story, but that kind of makes my same point about that. I never can remember that kind of stuff. There's a video game that was in the movie theater arcade in my hometown when I was little, and I never got a chance to play it, but I remember seeing the attract mode a lot. And in the attract mode, you were in like a warehouse. It was like a side-scrolling, like beat 'em up kind of game. And you were in like a warehouse-looking location, maybe like a hotel or something. Anyway, it had like an upper floor with like ladders and things. and enemies would like come out of the doors and start like shooting at you, or sometimes they would like crawl down the ladders and start fighting you and stuff like that. And so doors were always opening, and there was all this like dynamic stuff going on in the background. And I remember as a kid being like, oh man, I really want to play that game. That looks super awesome. Like I want to like play this game where there's like background things happening. I can't find that game, and the reason I can't find it is because I'm not even 100% sure it's a game that actually existed. Do you know what I mean? Like I don't remember if it's a game that I really remember being in the arcade, or if it's a dream that I had based upon a game that was actually in the arcade, right? Because like what I just described, there's any number of beat 'em ups that like kind of look like what my mind's eye is seeing, right? So that's kind of how I am when it comes to like stuff like that. Like, what does it triple and double equals mean? It's like, what language we're talking about again? I can't remember. But anyway, that sounds correct, but I'm not 100% sure. I'll look that up to double check. But yes, I believe Alex is correct in saying that triple will automatically type convert as
I'm
well.
looking it up right now.
Are you? Well, we got to know. We can't go on with our lives without knowing the answer to that question.
Also, I realize why that guy's so creepy.
Why is that?
Constantly stares directly at the camera.
Yeah, actually, it's funny you should say that.
He has,
I
like,
actually
dead
heard just the other day
eyes.
that Zoom meetings
Oh yeah.
can actually set off your fight or flight response
Yeah.
because human beings don't like being stared at.
It's
And I know
terrifying.
exactly what they mean because I was in the meeting I was in yesterday. Everyone was looking directly at me when I was talking, and I was like, it's weird because when you're in a group setting, like I'm looking at you, right, which is fine, but I can also look around the room, and there's, like Alex, for example, is like on the computer, so he's like looking down, and not everyone is looking directly at me. In a Zoom meeting when you're talking, everyone's focus is on the screen, and so they're all looking directly at you, and it's very unsettling. Like there are like plenty of times that like I'll be okay, so I'm like hyper aware that I'm being watched, and it creates this weird like surveillance feeling. Like I'll go to like check my email or something during a meeting, and I'm like, do you know what it's like someone's standing over my shoulder, like even though they can't see what I'm doing, it's the fact that they're like that I can feel their eyeballs on me, and it's very, very unsettling. But yeah, you're exactly right. He's just like
He has
looking.
He has no candor for being in front of the camera. Like,
No, not at all.
He's actually okay at talking.
He is, yeah, but like his like.
way of, like, he's just like.
It's like very wooden. He's just like,
unblinking,
so now what you would
super
want to do
unmoving.
is you would want to look at and he's just like staring into my soul while he's like, yeah.
Yeah. It's,
No,
it's a lot better when he starts coding, but then he's in just like the tiny circle in the bottom.
Yeah,
Because he's looking at the computer when he does that.
right.
But at the beginning, it's like.
That's what I like about Danny Crossing, the guy, the Danish guy, is that he's always like at an angle. He's always looking this way. So he'll occasionally look into the camera to make a point, but for the most part, he's looking at his monitor, which is like off to one side, so he can like type while he's talking.
Yeah.
And yeah, I much prefer that. Like I do not like when people stare into the camera.
It's creepy.
I actually used that exact principle when I was doing my undergraduate thesis because I had several there'd be like really intense moments in these scenes where like the first time the guy like places a bet on like a sports team like with a bookie or whatever. They're both like it's a shot from the perspective of the other person, so they're looking directly into the camera when they're talking. Later on, there's a scene where the guy's brother is like making a deal with this like gangster or whatever, and I use the exact same concept where they're like talking directly into the camera. And I remember my like assistant director, he was like, I don't know if that's a good idea, man. He's like, that's gonna be really unsettling. And I was like, well, that's the point. Like people get creeped out when like someone is like staring into their eyes like on a screen, and that's what I want to do. I want to like creep them out basically, underscore how unsettling it is that like what is going on. And so I like had them like looking directly like da 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 da, like looking directly into the person's eyes or whatever. But yeah. So did you find an answer to that question?
Oh yeah, that's right. According to MDN, the strict equality compares two values. Neither value is implicitly converted to some other value before being compared.
And that's triple?
Yeah, that's the triple, the strict. Whereas the loose equality compares two values for equality after converting both values to a common type.
Yeah, that makes sense. So if you were, I'm trying to wrap my mind around it now that I'm thinking about it. Okay, so if I was wanting to see, I would want to use triple if I was wanting to test whether like A and B are both equal to 15. Right? But if I wanted to compare if A and B are equal to each other, I would use double. Is it right, or would it be the opposite?
Well, like I think if you have a string that's 15 and a number
Yeah,
that's
that's
15, and you
yeah.
use the loose equality, then they'll be equal.
They'll be
If you
equal,
use the
but
strict equality, they won't.
which is triple, right? Triple is strict.
Yeah.
So if I were to use that, it would equal false. That makes sense. Okay, that makes absolute sense. Yeah, yeah. Okay, okay. But yeah, if one was a string and one was a number, and I use double equals, it's going to convert them both to like integers, for example, so that we can.
Right. I mean, you test it actually just to make sure.
Oh yeah, yeah. I guess we could.
See if it works.
But anyway, okay. So that's reference versus value, and as well as closures. Now, hopefully, that gave you at least a little bit more of an understanding of scope and like data processing, basically, like data structures, if you will, like how the actual program is structured. Hopefully, also, I'm thinking about including the video that we just watched in 120. Even though it's talking about JavaScript, not Python, I think that that's worth explaining to people in one. What do you all think? Do you feel like that would have been beneficial to you to like just have that discussion in 120?
Yeah, I mean, it's not like a super complicated.
Yeah, I would tend to agree, and I've never really thought about it before because it's specifically about JavaScript. But I don't know, maybe in the future it might not be a bad idea just to be like, hey, we're gonna take a quick sidebar. We're gonna talk about JavaScript for a second, but the principle is the same, right?
Yeah.
Okay.
Yeah, I
Any
tested it. It works.
excellent.
If you take a string and set it to 15, and you take just a regular, well, if you make a variable that's a string 15 and then a variable that's a number 15, and you use the loose equality, it'll say true. But if you use the strict 3 equal signs, it'll say false.
Okay.
That's fascinating.
Okay.
That's fascinating. Cool. Thank you for looking that up. That's awesome. That's
I
awesome.
just kept it in the console.
Yeah, that's great. See, like we can all, myself included, we can always be learning. Learning things. Okay. My guess is the answer to this question is no, as we've just been having a fairly fruitful conversation. But any questions, concerns, comments, thoughts, ideas? Nope. All right, come back at 10 a.m. and I will have that video posted for you all to watch and work on the really cool Zoom replacement program.